In this video, we delve into the world of knowledge graph, starting with the introduction to LangGraph and its relation to the more general concept of a knowledge graph. We'll then explore the LangChain model, that is a machine learning variant of a Lang-former architecture and its application in natural language processing tasks. Finally, we briefly touch upon Markov chains, which is a mathematical model used to describe sequences of events and its relevance to understanding the concept of LangChain and knowledge graph. So let's get started with understanding what is LangGraph. Basically, LangGraph is a library within the LangChain ecosystem designed to help developers easily create stateful multi-actor applications using large language models. It simplifies the development process by allowing users to define, coordinate, and execute multiple LLM agents in a structured manner. At its core, LangGraph uses a directed graph structure where the nodes represent LLM agents and the edges represent communication channels between them. And by creating and managing this graph structure, LangGraph ensures that agents perform tasks in the correct order and exchange the necessary information for a seamless user experience. LangGraph also handles state management automatically, which means it keeps track and persists information across multiple interactions, maintaining context and responding appropriately to new inputs. And this feature is crucial for creating sophisticated agent runtimes. Using LangGraph offers several advantages, including simplified development, flexibility, scalability, and fault tolerance. Developers can focus on the high-level logic of their applications without worrying about the intricacies of state management and coordination. So with LangGraph, they can build highly customized, scalable applications tailored to their specific use cases. So to summarize this, we can say LangGraph is a powerful tool that helps developers build complex multi-agent applications, leveraging large language models, providing a streamlined, flexible, and robust development experience. Next comes knowledge graph. Now, this knowledge graph is a structured representation of knowledge that organizes information as a network of interconnected entities or the nodes and relations, that is the edges between them. In simple terms, it is a map of concepts and their connections in the real world or within a specific domain. Imagine a network where nodes represent entities like people, places, events, or concepts, and edges represent relationship like is a, has a, lives in, works for, is part of, etc. Now, this network can be queried, searched, and analyzed to extract insights and answer questions related to the entities and their relationship. For example, consider the knowledge graph about movies. Now, in this graph, nodes could represent movies, actors, directors, production companies, and genres, and edges would represent relationship such as directed by, acted in, produced by, belongs to, is a type of. So with this knowledge graph, you could easily find all the movies directed by the specific director, all the actors in a particular movie, or all the movies belonging to a particular genre. So in this way, knowledge graph can help organize and understand vast amounts of complex information, enabling more intelligent and efficient analysis, recommendations, and decision making. Now next comes LangChain. Now this LangChain is a machine learning model designed to generate human-like text and perform tasks related to natural language processing. It is an open source project that implements a variant of long-former architecture, which is a transformer-based model designed for processing long sequences of text. LangChain is primarily used to create chatbots, language tutors, content generators, and other applications that require generating text in a coherent and natural way. And this model can be fine-tuned for specific tasks by training it on the relevant data set. So to illustrate this concept, imagine you have a basic chatbot that only responds to simple questions with canned responses. So with LangChain, you could fine-tune the model on a large corpus of text and make it capable of generating more nuanced and context-aware responses to user queries. So in simple terms, LangChain is a sophisticated algorithm that can be used to create intelligent text-based applications by leveraging the power of machine learning and transformer models. Next comes Markov chain. Now this Markov chain is a mathematical model that describes the sequence of events where the probability of each event depends only on the state attained in the previous event. In other words, the probability of a particular event occurring is determined by the current state and the history of preceding states is irrelevant. So this type of model is named after Russian mathematician Andrei Markov. So to better understand this concept, consider the simple example of a coin toss. Now when you toss the coin has two states, heads or tails. Each time the coin is tossed, it has 50% chance of landing on heads, that is P, and a 50% chance of landing in tails, that is 1 minus P. Now this information can be represented as Markov chain. So at each step, the current state, that is head or tail, determines the probability of transitioning to the next state. Transition probabilities can be represented in a matrix like this. So where the rows and columns represent the states and the values in the matrix represent the probabilities of transitioning from one state to another. And in our coin toss example, the transitional matrix would look like the above one, like this. So here this matrix shows the probability of transitioning from one state to another. For instance, if the coin lands on the head, there is a probability of P that the next toss will also result in heads, and the probability of 1 minus P that the next toss will result in tails. So this Markov chain are widely used in various fields such as finance, physics, computer science and engineering. In machine learning, they are used to model text generation, prediction and language modeling among other applications. Thank you.